Everyone's been asking the same question. What on earth is happening with 3I/ATLAS? And honestly, I wish I had a simple answer. But as of today, November 9th, 2025, the only thing that's clear is that this isn't behaving like anything we've ever seen. Not like a comet, not like an asteroid. It's something else. What I'm about to tell you marks the most extraordinary, unsettling week in interstellar research since the discovery of Oumuamua back in 2017. Two things happened in just 6 days, and both completely upended our understanding of what's out there. It all began on November 2nd. A new object appeared, right between 3I/ATLAS and Earth. It was found by none other than Gennady Borisov, the same man who discovered 2I/Borisov in 2019, the only confirmed natural interstellar comet. The guy knows what a real comet looks like, but this one wasn't right. He named it C/2025 V1 Borisov. Unlike typical comets, it had no tail. Nothing. Just a tight, bright little coma, unnervingly compact. Its orbit was nearly interstellar, with an eccentricity just over 1.0. That alone was strange enough. For 6 days, every major observatory on Earth tracked it. 8 out of 10 reported the same anomaly. No tail, no sublimation, no dust trail, just that eerie glow. Then, on November 8th, right at perihelion, it simply vanished. Gone. Disintegrated as if it had never been there at all. And that same day, 3I/ATLAS erupted. 7 distinct jets of plasma shot out from its surface. 7. This morning, when I was interviewed on Newsmax, the host asked me a question that's been haunting every astronomer this week. He said, "Did 3I/ATLAS maneuver?" And I told him, without hesitation, yes, it did. It deviated from the path gravity alone should have dictated. That's not speculation. That's data. The velocity change we observed would have required the same recoil as if a jet engine blasted out 5 billion tons of matter. Just think about that. That's the amount of energy it would take to move an object like that against the sun's pull. Then came the second question, the one that really matters. What about the Borisov object? Could it have released something? I paused before answering because I wanted to be precise. My reply was simple. That's the key question. Whether it released any smaller objects, perhaps probes, directed toward the planets. Yes, I use the word probes, not fragments, not debris, probes, because what we're seeing doesn't fit natural behavior. When a normal comet approaches the sun, it heats up, ice turns to vapor, gas escapes, and radiation pressure pushes that material outward, forming the classic glowing tail. It's simple physics, beautifully predictable, but 3I/ATLAS refuses to play by those rules. As of this morning, observers like Michael Yeager have documented at least 7 jets emerging from its surface, some aimed toward the sun, others away from it, and a few at completely illogical angles that defy radiation pressure dynamics altogether. Stephen Burns, a geophysicist who's been tracking it minute by minute, put it best. You can't even call it a tail anymore. These are jets, distinct, structured, and intelligent in their direction. And he's right. This isn't outgassing. It's something far more complex. Let's look at it mathematically. If 3I/ATLAS were losing mass naturally, the observed non-gravitational acceleration would demand that it eject more than 10 to 20% of its total mass during perihelion. And yet, the directionality of these jets means the majority of that ejected material should have cancelled itself out, leaving behind an enormous debris cloud. We should be seeing a glowing cloud of gas, billions of tons in size, lighting up the sky like a beacon. But we don't. The region around it is dark, empty, silent, and that silence feels deliberate. Hundreds of telescopes are now locked on 3I/ATLAS. Every major observatory is watching, waiting for the same telltale sign, the cloud. If we see it, we'll know we're dealing with a natural comet, one that simply broke apart near perihelion, just as physics predicts. Its gases, its dust, its chemical signature, All of it would confirm the simplest answer. Mystery solved. Mystery. But if the sky stays clear, if there's no massive gas cloud despite the violent acceleration we've measured, then we have to face a possibility no one wants to say out loud: technological propulsion. That's not science fiction, it's just math. Chemical rockets push exhaust at around 3 to 5 kilometers per second. That's 10 times faster than anything natural sublimation could manage. Ion propulsion, even faster. 10, 20, 50 kilometers per second. When propulsion is engineered, you don't need to lose tons of mass to change your trajectory. You trade mass for precision. You move efficiently, and that's the test. Brutally simple, frighteningly clear. Either we see a vast glowing cloud or we don't. Either it's natural or it's not. We're standing right on that threshold, waiting for the universe to tell us which. Now, let's talk about V1 Borisov, because this is where everything starts to blur, where coincidence begins to feel like choreography. On November 2nd, Gennady Borisov spotted it. NASA's JPL confirmed it. The Minor Planet Center catalogued it within hours. The orbit came in at a wild inclination, 113 degrees relative to the ecliptic, practically perpendicular to 3I/ATLAS's path. Their trajectories, according to every model, should never have brought them anywhere near each other. The closest their orbits come is 75 million kilometers apart, and without some kind of non-gravitational force, those paths don't cross. Period. So, by all conventional logic, V1 Borisov has nothing to do with 3I/ATLAS. Nothing at all, unless 3I/ATLAS is capable of propulsion. And that's where things get strange, because from our vantage point, right between Earth and 3I/ATLAS, something appeared. Bright, compact, no tail. Over 6 days it flared, then dimmed, then, at perihelion, it disintegrated. Gone. And that same day, 3I/ATLAS lit up, firing 7 jets of plasma. 7. I'm not making wild claims. I'm just showing you the timeline. One that's becoming harder and harder to call coincidence. The question we're now forced to ask, the one that feels more like science fiction than astrophysics, is whether 3I/ATLAS could be a kind of mothership releasing smaller probes into the inner solar system. If that's true, those probes wouldn't look like much. They'd be tiny, quiet, easy to miss until they were close. No tails, no outgassing, just faint, strategic flashes of light before disappearing or deactivating. And when you look at it that way, V1, Borisov fits the profile perfectly. Appeared suddenly, brightened, lingered for 6 days, vanished, and right after, the mothership changed behavior. Is that proof? No, but it's enough to warrant serious investigation. That's why I've instructed my team at the Galileo project to begin a deep data sweep, tracking for smaller, faint objects near Earth, anything that might have been deployed. Now, before I finish, I have to mention the part that's been keeping me up at night, the color anomaly. After perihelion, 3I/ATLAS changed. It didn't dim, as comets usually do. It brightened 5 times brighter than before its closest pass. And its hue shifted. It turned blue, bluer than the sun itself. Think about that. The sun's photosphere burns at nearly 5,800 Kelvin. But even then, 3I/ATLAS somehow reflected a colder, sharper spectrum. A cooler object should glow redder, not bluer. Physics says that's impossible. And yet, there it is. Every spectrum, every observation says the same thing. Something out there is breaking our rules or rewriting them. That's blackbody radiation, basic thermodynamics. Hotter objects glow blue, cooler ones glow red. It's one of the simplest truths in physics. But 3I/ATLAS breaks that truth wide open. It glows bluer than our sun. For that to happen, it would need an internal energy source hotter than 5,800 degrees Kelvin, or an entirely different mechanism. Ionized plasma emissions, or something we simply don't understand yet. On October 3rd, China's Tianwen-1 orbiter circling Mars turned its high-gain camera toward 3I/ATLAS. The object was about 30 million kilometers away. The images it sent back left even seasoned astrophysicists speechless. A blue-green nucleus. No tail, no coma, just a living glow. Compact, cohesive, self-contained. Spectral data from those same frames showed a dominant blue wavelength, suggesting ionized carbon, or an energy process that doesn't fit into anything we'd call thermal physics, because comets, as we know, scatter light through dust. Dust reddens light. That's why most comets look like dying embers. But this was the opposite. A blue shift means something smaller than dust is scattering the light. Plasma, or perhaps, though we whisper it cautiously, an artificial reflective surface. The Chinese data didn't disprove the mystery, it confirmed it. And I have to say this, and I mean it. When the Chinese National Space Administration released those images within days, they did what science is supposed to do. They shared. They didn't hoard data. They didn't classify it. They opened the sky. Meanwhile, NASA's Mars Reconnaissance Orbiter captured its own images of 3I/ATLAS around the same time, but those remain administratively delayed. So credit where it's due. China showed transparency. Science has no borders. The sky doesn't wear a flag. When one nation hesitates, another steps up. That's how humanity moves forward, together. Now, here's what we know for certain about 3I/ATLAS, the facts that no one disputes. It was discovered on July 1st, 2025, by the Atlas Survey Telescope in Rio Hurtado, Chile. At the time, it was out near Jupiter's orbit, 4.5 astronomical units from the Sun. Its trajectory was unmistakably hyperbolic, with an eccentricity of 6.137, the highest ever recorded. Oumuamua's was just 1.2, Borisov's was 3.4. This one, 6.137. There's no argument. 3I/ATLAS came from the stars. It made its closest approach to the Sun, perihelion, on October 29, 2025, at exactly 7:47 a.m. Eastern Time. Distance, 203 million kilometers between Earth and Mars. Speed, 68 kilometers per second relative to the Sun. At that distance, solar radiation blasted its surface with 770 watts per square meter, enough to boil off the outer layers of any natural comet. But here's where it gets strange. Perihelion happened during solar conjunction, when the object was directly behind the Sun from Earth's view. In other words, 3I/ATLAS vanished behind the blinding glare just when it mattered most. Coincidence? Some say no. The geometry is too precise, as though the timing was intentional. I don't speculate, I observe. But that alignment, that precision, is hard to ignore. Even then, space-based instruments caught glimpses. NASA's Stereo-A spacecraft, SOHO, and the GOES-19 weather satellite all tracked it during that hidden passage. The James Webb Space Telescope, observing earlier in August, detected something extraordinary in its spectrum: carbon dioxide, traces of water ice, carbon monoxide, and carbonyl sulfide. Meanwhile, the James Clerk Maxwell Telescope in Hawaii picked up something else: hydrogen cyanide, a deadly gas, spewing out at an accelerating rate, from 1.5 times 10 to the 25th molecules per second in early September to 4.5 times 10 to the 25th by mid-month, roughly 2 kilograms per second. That's chemical activity, all right. But here's the paradox. Despite all that outgassing, there was no visible tail, no massive debris cloud. It was venting chemistry, but the light stayed clean. Then, on November 8th, it erupted. 7 bright jets in perfect symmetry. The brightness spike that followed was unlike anything seen from an Oort cloud object. Data from Stereo, SOHO, and GOES-19 showed a brightening curve that defied physics. Its luminosity didn't follow the usual inverse square law. It followed an exponent of negative 7.5 compared to the usual negative 2 or negative 3 for natural comets. In simple terms, it brightened fivefold after perihelion, and it turned even bluer. If this were normal sublimation, we'd see a cloud, a colossal one, billions of tons of dust and gas reflecting sunlight spread wide across the void. But the sky remains empty, And that brings us to the question no one wants to ask aloud. If 5 billion tons of gas were never released, then what exactly powered the jets of 3I/ATLAS? In science, there are moments when the evidence is about to speak louder than speculation. This is one of them. The December observations will settle the question. On December 19th, 2025, 3I/ATLAS reaches its closest approach to Earth, 269 million kilometers, or 1.8 astronomical units. That will be our clearest observational window yet. The Hubble Space Telescope and the James Webb Space Telescope will both acquire high-resolution spectra. We will measure outflow velocity, mass flux, and jet composition with precision never before achieved for an interstellar object. It's a simple, falsifiable test. If we detect massive mass loss, then the case is closed. It's a natural comet disintegrating under solar heat. But if we don't, if the object maintains its acceleration without significant outgassing, then we're looking at something fundamentally different. Technological propulsion becomes the leading explanation. Chemical rockets produce exhaust speeds of just a few kilometers per second, an order of magnitude higher than any cometary sublimation. Ion thrusters, however, can reach 10 to 50 kilometers per second. That's the key distinction. At higher exhaust speeds, far less material is needed to achieve the same push. That's what we'll test in December. It's a binary outcome. Either we see a vast debris cloud or we don't. Either it's natural or it's technological. I've been asked repeatedly about probabilities. Before the latest observations, I placed the likelihood of 3I/ATLAS being of technological origin at 40%. That number hasn't changed yet. I'm waiting for the data, because within weeks, we'll know more than speculation could ever tell us. It's like a blind date on an interstellar scale. You don't decide until you've seen the other side. Now, there's a crucial question I've raised publicly. Did 3I/ATLAS release probes toward the planets? That's what we're watching for. NASA can monitor the vicinity of Mars. The Galileo project at Harvard will continuously analyze incoming data near Earth's orbit. If smaller objects were deployed, they will be detectable as they cross planetary trajectories. We have the tools. We have the expertise. We're watching. After December 19th, the object continues outbound. On March 16th, 2026, it will pass within 54 million kilometers of Jupiter. At that time, NASA's Juno spacecraft could attempt to image it directly or even scan for technological signatures, radio transmissions, electromagnetic anomalies, or any sign of artificial structure. By then, 3I/ATLAS will be moving through Gemini, leaving the inner solar system behind, perhaps forever. Now, let me briefly address the political and public response, because transparency matters. On October 31st, Representative Ana Paulina Luna sent an official letter to NASA urging the release of all high-resolution imagery and data for open scientific review. She's coordinating discussions with both NASA and the Pentagon to ensure that the high-rise images from Mars orbiters captured on October 2nd are made public. That's appropriate oversight. Science thrives on openness. The public's response has been extraordinary. I've received messages from parents around the world describing how their children now rush home from school asking about 3I/ATLAS. How many are asking for telescopes this Christmas inspired by discovery itself? That is the essence of scientific curiosity, wonder transformed into participation. When Kim Kardashian asked NASA about 3I/ATLAS on X, they replied in 11 minutes. When Congresswoman Luna submitted a formal request, there was silence for days. That contrast tells you something about institutional priorities. It shouldn't be that way. Science belongs to everyone. Data should be open. Transparency accelerates understanding. Whatever the final verdict, whether 3I/ATLAS proves to be natural or something more, its scientific legacy is already secure. Unlike Oumuamua, discovered only after it had passed perihelion, 3I/ATLAS was detected months before its closest approach. That gave us an unprecedented opportunity, detailed monitoring both before and after its solar encounter. We know its trajectory, its composition, its maneuvers. We've observed 7 distinct jets launched in multiple directions. We've measured a 5-fold increase in brightness. We've seen it appear bluer than the sun itself. And we've documented a brief companion event, an object that appeared for 6 days exactly between Atlas and Earth and vanished the very day Atlas's jets ignited. Those are facts, documented, reproducible, testable. The coming December data will close the loop. The debris cloud test, the spectroscopic readings, the velocity measurements, that's what science demands. We simply wait 6 weeks. And as I said on News Nation, let's hope 3i/ATLAS doesn't deliver any unexpected gifts to Earth this holiday season. That wasn't a joke. If smaller probes were deployed, we must track their trajectories. We must understand their intent, if intent exists, because planetary defense isn't science fiction. It's the responsible way to face the unknown. Now, before I conclude, let me ground this discussion with one final technical note. The outflow velocity test is simple physics. Sublimating water ice yields gas velocities around 0.5 kilometers per second. Carbon dioxide sublimation can reach about 0.8 kilometers per second. Those are the natural limits of thermally driven outgassing. Anything faster and sustained would demand a technological explanation. That's the threshold we'll be testing. And in just a few weeks, the universe itself will provide the answer.